Hello everyone, this is Nitrogen here and welcome back to another video. Today we are taking a look at a technological marvel. It is the James Webb Space Telescope, or JWST for short. I've got a nice photo of it here. Today we will be taking a look at the brief history of this particular telescope, its specifications and technological details, and its importance on humankind. But of course, before the video starts, make sure to leave a like and subscribe, as it would be a great help to me. Anyways, without any further ado, let's get into the topic then. So, the James Webb Space Telescope. You might have not heard of it, and that is perfectly fine, but you must have heard of the Hubble Space Telescope. If you have not, I would be very sad. The James Webb Space Telescope is designed to be the successor to the Hubble Space Telescope. Early planning of this telescope began in the late 1990s, led by NASA. Back then, the budget of this telescope was estimated to be around $500 million, which is a lot of money. However, by 2005, the Goddard Space Flight Center, a subsidiary of NASA, which was responsible for the R&D of the JWST, re-evaluated the cost and estimated the total cost to be $4.5 billion. But it doesn't end here. By the time of its launch in December 2021, which by the way is 14 years behind the first planned launch date of the telescope, the cost of the JWST has reached a staggering $9.7 billion, which is absolutely bonkers. You might ask, what in the world made this telescope so bloody expensive? Well, most of the money is actually spent on research, development and extensive testing rather than the cost of constructing and launching the telescope itself. Let's take a look at the telescope in detail. The James Webb Space Telescope is made up of three primary sections: the optical telescope element, the integrated science instrument module, and the spacecraft bus. Each of the sections has a distinct role. The optical telescope element is the actual part of the telescope that we see. It has a primary mirror with a diameter 6.5 meters made of gold-plated beryllium. It has 18 hexagonal segments to allow some mirror segments to fold up during launch in order for the telescope to fit in the Ariane 5 rocket provided by the European Space Agency. The mirror segments can be tuned using small motors mounted behind the mirror called actuators. This allows the light hitting the primary mirror to be reflected to the secondary mirror and remain in focus. There is also a fixed tertiary mirror and a steering mirror located in the aft optics subsystem, which occupies the middle hexagon, surrounded by the 18 mirror segments. This is the eye of the telescope. If the optical telescope element is considered the eye of the telescope, then the integrated science instrument module is the brain of the telescope, being able to process the light coming from the lenses and formulate an image from different spectrums. The JWST can observe the universe in near and mid-infrared spectrum, and that is all thanks to the near-infrared camera and the mid-infrared instrument, which creates the image using IR sensors. There are two more instruments in the module providing a variety of supporting functions other than to create the telescope's image itself. Because of the nature of infrared imaging, the telescope and the scientific instruments must be kept below 50 Kelvin in order to actually create a relatively noise-free image. Therefore, between the spacecraft bus and the two other sections, a large sunshield system has been fitted to block and reflect solar radiation. It has 5 layers of very thin aluminium-coated membranes that would fold up inside the rocket fairing and would be deployed when launched. The spacecraft bus is a support module providing electricity, heat radiation, communication with the Earth and propulsion. A solar panel, radiator system and an antenna was installed on the spacecraft bus. Some small rocket engines and reaction wheels are also used to give the telescope maneuverability. The telescope was launched in French Guiana in December 2021 on an Ariane 5 rocket. It is currently orbiting the Sun-Earth L2 Lagrange point. Now, If you don't know what a Lagrange point is, it is a point of relative gravity balance between two celestial bodies where a third, much smaller object can orbit or stay at relative equilibrium. We will not go into too much detail about how a Lagrange point works since it involves some fairly complex maths in the form of limited three-body problem, and I have no idea how it works, so there you go. But what you need to know is that since this is not a completely stable orbit, the JWST must use its own thrusters every once in a while to maintain its halo orbit. This orbit is used so that it can stay away from the already highly polluted low Earth orbit while not being too far away from the Earth, allowing fast and efficient communication with the control centre. Now you might ask, all this hard work, all this sophisticated machinery, all this money spent, and all the years taken for the telescope to materialise, what for? It does a similar thing to its predecessor, the Hubble Space Telescope, albeit at a narrow wavelength range. So I guess it would be more appropriate to compare the upgrade as replacing an iPhone with a larger red camera. You do get less functionalities, but it does so well in the aspect that it does well that it doesn't really matter. The telescopes, thanks to its exponentially larger lens and therefore aperture, can see further than Hubble, and as a result, it can see the universe at a younger age, which helps our understanding of the formation of the universe. It is also tasked with observing supermassive black holes and exoplanets for the interest of humankind. It is hard to exactly describe how important the James Webb Space Telescope is to the advancement of human science and human evolution. But you have to know that being able to peek into the beginning of time is an ability that many would dream of. Luckily, the JWST can do exactly that. This telescope is an eye that not only creates fancy, sharp images of nebulas, but also gives us an insight into a young universe. Its integrated spectrometer helps us understand the chemical structure and physical properties of extraterrestrial bodies, and the infrared camera sensor helps our scientists to understand stellar formation, universe evolution, and a bunch of other fancy stuff that could not be done with any other telescope. Currently, the James Webb Space Telescope has finished deployment and is at the end stage of its testing. The first images captured by the telescope will be revealed to the public on 12th July, demonstrating the telescope's capabilities and announcing the official operation of the telescope. I am super hyped about this, and make sure to stay tuned for the images which will be released on both social media and NASA's own website. Now, I think that is a lot of content for today. I hope you were not bored to death watching this video, and hopefully you learned some interesting things about the most powerful space telescope ever made. I surely learned a lot by making this video. Before you go, make sure to leave a like and subscribe so you won't miss any more awesome videos from me. Thanks for watching, and I'll see you in the next video.